Okay, in the last video we took a look at how to construct this tree diagram, but now we want to see how we use this to go ahead and actually answer probability questions. Let's see what we have here for part B. What is the probability that the person selected here is unemployed? Okay, so I know in probability notation I'm looking for probability of U. Well, notice here that really what I'm going to be interested in finding is all of the times when I would have ended along this U branch. Notice that I would say that I'm interested in all the males that are unemployed, and to get there, that's a total of 0.036. I want to know all the females that are unemployed, so how do I get to there? Well, I go down the 0.4 and then the 0.045, and so I can take those two values and just add them up. So this is 0.036 plus 0.018, and when I add those together, I get 0.054. Notice that's exactly the same answer we got on the last question as well. We just arrived at it with a slightly different approach. We'll take a look here at part C. We can also do some other questions here. Suppose here that the person selected is female. Okay, perfect. Person selected is female. Oops, excuse me. And what is the probability that she is employed? So notice that the question here is conditional. I know that the person is female. I want to know what are the chances that they're employed. So this question is actually so simple that I don't really actually have to do hardly any calculations at all, because notice that it's already kind of in the picture. If I walk down the female branch at the start, what are the chances I end up at unemployed? Well, I can see that value is sitting right here. So this is 0.955. I'll even state this value is shown in the diagram. And so we have no reason to actually go ahead and use any sort of fancy formula here to arrive at that value. So that's great. Conditional probabilities can just be spotted oftentimes within the table. Well, let's take a look at part D to see what this question asks. Suppose that the person selected is unemployed. Okay, so I'm again given something conditional. I know the person is unemployed. What is the probability that the person was male? Well, let's see if this conditional probability is already sitting in the diagram. I would need to go down the U branch and then ask the question, what are the chances I end at M? Wait a minute. Go down the U branch and then end at M? Notice I don't really have that, right? I have to start by going down male or female. I can only do givens that are given male or given female, since that's kind of the way my tree progresses. And I could try to reorganize my tree to maybe have unemployed and employed down here at the start, but then I actually will see that I don't have enough information to fill in that tree diagram. Don't worry though, I always still can go back to relying on my formula if this value is not in the actual table. I'll go ahead here and make this note that this value is not shown in the diagram. But again, it's still super easy to get. Do you remember the formula? Well, if you don't remember it, go back and take a look at it. Go look at that formula sheet for this section, or for this chapter, and see what it is. There's probability for M given U. That should have come out as probability of M and U over probability of U. Well, notice these are all things I can find directly from the tree diagram. Let's find M and U first. So that would be go down M, go down U. M and U is 0.036. Perfect. 0.036. Probability of U, well, actually, we can see here that we already calculated that, but if I didn't already have that calculated, I would just say, well, what are all the different ways I can arrive at U? Let's add all of those things together. So notice we already have that, so this is 0.054. If I was to go ahead and actually divide these and simplify it out, I think I get 2/3, which is the same as the value 0.6667. So this is kind of nice. It's important here to see that what we're seeing here in example 1 and example 2 is that neither representation of the tree diagram is better, but they just, like the tree diagram or the table is better. They just offer a different way to kind of think about the organization. Tree diagrams are great if you start with a lot of information about conditional probabilities, right? Notice here I started with conditional probabilities and I just organized it immediately. If I started with ands, it's way easier to set up a table. So don't get trapped into thinking you always need to do a tree diagram or you always need to do a table. You do tables when you have ands, you do tree diagrams when you have conditional probabilities. In the next video, we'll take a look at how we can go ahead and interpret a little bit more about what we've actually seen here in this example and be able to answer some additional questions of a slightly more complicated nature.